Assalamualaikum and a very good day class. So now we are in the next subtopic which is still under first order ordinary differential equations, but we'll go how can we solve first order ordinary differential equations in terms of linear equation. Here class, by the end of this chapter, you should be able to determine and find the general solution of the linear equations. So, first thing that we need to know is what is linear equation of ODE. Actually, you have learned about this in week 1 video. Linear equation is a one type of ODE that occur frequently in application problem, and it has a general form of dy over dx plus py equal to q, whereas here p and q are functions of x only. And this equation, we call it as linear equation since we can see here y and also its derivative dy dx are the first degree. That is why here it is degree 1 and also dy dx is degree 1. And if you see here, there is no multiplication between y dy dx with its dependent variable, because p and q here are functions of x only, so that it's fulfill all the condition about linear equation of ODE that you have learned in week 1. But to solve this one later, you need to understand about this equation dy dx plus py equal to q, because before you solve using this method, you need to write your equation into a general form of this one. How do we know that the equation, we can call it as a linear equation? An equation is said to be linear if it has the form of ax dy dx plus bxy equal to cx. Here the multiplication involving dy dx is only function of x. Multiplication involving y only function of x as well, and also it is equal to some function of x, where here ax, bx and cx are constants or function of x or constant. And to solve this linear equation, we need to transform this one into general form. Dy dx plus py equal to q, where is p and q also function of x. If I want to write this one in general form, means that I need to make a coefficient of dy dx equal to 1. So now I have a of x dy dx plus b of x y equal to c of x. So to make this coefficient equal to 1, I need to divide the whole equation here with a of x. I divide here with a of x. This one divide with a of x, and also this one we divide with a of x. This one will got equal to 1, means that I will have here dy dx plus b of x over a of xy equal to c of x over a of x. And class, if you see, now the coefficient of dy dx equal to 1, which is in this form, and this one some function p, which is p is a function of x times y. So here, this one actually is p of x. And then we have equal to q, means that this term is q of x. So by writing our equation in this form, we have write it in terms of general form, whereas here p equal to b over a and q equal to c over a, and here we leave the coefficient of dy dx equal to 1. So class, we go to this example. Identify whether the equation is linear or not. In this case, we know general form of this equation, of the linear equation, is dy dx plus p of xy equal to q of x. Our first step here, we need to write this equation in this general form. I can rearrange this equation. I will have here tangent x dy dx equal to x squared sine x minus cos x multiplied by y. And then this term, actually it is in terms of some function of x multiplied with y. So I can move to this side. I will have here tangent x dy dx plus cos x y equal to x squared sine x. And then class, I need to make the coefficient of dy dx equal to 1. Means that I need to divide all for the whole equation with tangent x. Okay, so this one also we need to divide with tangent x. Means that here I will have dy dx plus cos x over tangent x times y equal to x squared sine x over tangent x. So class, this is general form of linear equation, means that this equation actually it is linear equation. And then next class we go to this example. Identify whether the equation is linear or not. In this case, directly you can see this one we have y to the power of 2. Here you have y multiplied with dy dx. So it is not fulfill the condition the condition of linear equation. In this case, we have a multiplication of the dependent variable, and also its dependent variable is multiplied by its derivative. So in this case, it is nonlinear ODE. Now class, when we have the equation in terms of linear equation, there are specific methods to solve that linear equation of ODE. These are the steps to solve linear equations of ODE. The first step, it is very important for you to rearrange the equation in the form of dy dx plus pxy equal to qx. Means that you need to write your ODE in terms of general linear equation. And then based on this one, you can identify P and Q. Means that you can get step number 2, get Px and Qx. And then when you got this Px, you can solve for P, which is here. Solve for the integration of P dx. That is, you need to integrate P without constant. Remember here, without constant. Once you integrate P dx, step number 3, you need to calculate the integrating factor. The integrating factor is given by rho x, which is equal to the formula of exponential and the integration of P dx. That is, this part actually comes from step number 2. Once you got the answer in step number 2, you can find the integrating factor by substituting integration of P dx in this formula. And then we can rearrange the equation in the form of d dx d rho y. This one is integrating factor from step 3. And also this one is integrating factor from step 3. Means that rho times y and here rho times qx. Once we got this one, we go to the last step. We integrate equation in step 4 with respect to x. That is, finally you got this solution. Rho y equal to integration of rho q dx. That is for this part. If we have a step number 4 here, d dx rho y, which is equal to rho qx, we can actually move this dx to this side. So we have d rho y equal to rho qx dx, and then here we integrate both sides. We'll got here rho y equal to integration of rho qx dx. So we integrate this one. Finally, you will got a function of y, which is rho. You can move again to this side.